Hello guys, so right now we're gonna discuss to you the topic about bitwise operators. And the bitwise operators in C programming has 6 types, and the first one is the end. It is the end operator. And also the second one is the vertical, which is the OR operator. And then this one, it is the XOR operator. And the fourth one is the complement operator. And the less than here, it is the shift left. And then this one here, it is the shift right. So this here are all the 6 types of operators in Bitwise in C programming language, and we were gonna tackle in this tutorial these 3. Operators in Bitwise operators. So you might ask, what is the meaning of bitwise operator? Well, it is the operator that can be used to add, subtract, minus, and divide in the compiler. So inside the CPU, we have this arithmetic logic unit, which has these mathematical operations like the addition, the subtraction, the multiplication, and division. And these bit level operations have this kind of operators, or bitwise, what we call the bitwise operators, that are the one who is making these operations, less like adding, subtracting, multiplying, and dividing. They're the ones who made this operations to make it successful. So without these operators, bitwise operators, there will be no operations just like the arithmetic operators or the modulo, because the one who do that kind of task is these bitwise operators. Without this, there will be no output for that operations. So that's how these operators are important. So we're just gonna have a brief discussion and example for this, so that you might be able to comprehend their basic functionalities. So right now we're gonna discuss to you the odd operator. So we're gonna just sorry guys, I was just gonna delete this one. I'm gonna erase that, and then we were gonna create this one. We're gonna create example for this end operator. So how does this operator work rather? Well, in its rule is simple guys. So you have to know first the rule for this. So its rule is the 2 operands should be having a value of 1. Otherwise, if it's not meet their requirement, then it will be the output will be 0. So for example, if we have here a 3, value of 3, and then 10, and then the value of that in binary number is 0 0 0 0 0 1 0 0 1 1, and then this 2 here is 0 0 0 0 1 0 1 0, and then we all know that these are the two operands, right? And then this is its operator. So how, as I have said earlier, that it will be 1, the output will be 1 if both of the operands are 1, otherwise the output will be 0. So as you can see here, where is the part that has 1 operands? So as you can see here, this is the 1, so this is only the value that has a 1 output. So otherwise the rest will be 0. So that is the output of 1. So the answer for this, or the answer for this, would be equivalent to 2 in decimal numbers. And let us check if it is working, it is really correct. So let's gonna delete this one, guys. So let's create a new terminal in here, and then we're gonna use this one here. So I have already created a code, and then I will just gonna run this one by one in each topic that we were gonna tackle. So in this portion here, in this row number 6, I have created an output that says that add and bit level operator and has this this bit rather this bit level operator and has this answer, which is %d and \n, and it has an operator which is a and bit operator, a bitwise operator. So let's check if this is gonna work. So this is how you could call out the a and b operator. So if you were gonna try to run this one, and you can see that the output is 2, where it is the same with our solution here in our equation, right? So this is correct. So that is how the AND works. But how about the OR? So about this one, this OR here. So I was just gonna remove this comment here, and then let's see if what we're gonna get. As you can see in here, it is A or B. So this A or B here will gonna work by having this rule, this kind of rule, that in OR, I'm gonna delete this one first. So in OR, this will just work. It's like this 3 0 0 0 0 0 1 1 0, and then the number 10, which is 0 0 0 0 1 0 0 1 0 1 0, right? So this one here, I'm gonna work like this. This 0 here will have an output 0, because why? The OR value has this rule that it will be 1, it will be 0 if both of the operands are 0, otherwise they are all 1s. So if both operands are 0, then it is 0. If it has 1, since it has 1, then it will be have an output of 1. So the rest will be 1. So this is the only one that can have an output 0. So the rest, in this 2 operands, it has already 1, so the result will be 1. So in this portion here, in this solution, we were gonna have this kind of output here, which is 1 0 1 0, which is equivalent to 0. No, it's this one is 1. So the output for this is 11. So let's try to check if it is really correct, what if our solution is right. So let's try to run this one, and then as you can see in here, it is 11. So The result of this is 11, so we have this answer. So that's correct, right? So now we're gonna have this last discussion, which is the XOR. What about the XOR, guys? So the XOR, we're gonna have this symbol, and then this symbol here have this rule that all of if the two operands has an opposite value with each other, then it will become 1. Otherwise, it will all be 0. So, for example, if this is the first operand, the second operand, it will have a 1 output. Otherwise, the rest of all that, it will become 0. So, it could be either this one or this one. So, it has the same output like that. So in this example 3 and 10, we're gonna create this one again, and then 0 0 0 1 1 0 0 1 1, and then 0 0 0 0 1 0 1 0. The output for this is this one has an opposite, right? So it has 1 value there, and then this one here is the same, so it will be 0, and then this one is gonna be 1. So the rest of this is 0. So this is the answer. So the answer for this is, it is 9. So let's try to check if it's correct. So let's see it in here. So as you can see, let's try to delete this one and this one as well. Then we're gonna run this one, and then it says here that the output is 9, so therefore the result is 9, and that's why we have this result 9, right? So that's how it works, guys. So this is all for now, and we're gonna discuss next topics for this exact types of bitwise operators in the next tutorial. And thank you for watching, and I hope you have learned something new, and goodbye.